In this video lesson, you will learn about CQRS design pattern. And the abbreviation CQRS stands for Command Query Responsibility Segregation. Let's see what this means. In CQRS design pattern, the responsibility of components in your application is divided mainly into two main parts, commands and query. And this is why the name of the pattern is Command Query Responsibility Segregation. Let's assume that we have a REST client application that communicates with our microservice. So when a client application communicates with our microservice, it will either send an HTTP request, like for example HTTP post, put, delete or patch, and it can also send HTTP GET request. We can think of HTTP requests like post, put, delete or patch as commands that perform certain operations and modify information in our database. And we can think of HTTP GET request as a query because it requests our microservice to return some information. So that's one easy way to think about it. But it's not only about HTTP requests that are coming from a REST client. As we continue working with CQRS design pattern in this video course, you will see that commands and queries is how the communication will be done within microservice and also between microservices. Whenever we want a microservice to execute a certain task, we will issue a new command. And whenever your microservice needs to return some information from a database, for example, we will use a query API. So think of a command as an intent to trigger an action. For example, create a new product. And think of a query as a request for information. Like for example, find product by ID. And how it technically works, you will see in details in the following video lessons. Now, notice that in this slide, the commands and query segregation is done within a single microservice. We have a single microservice that is divided into two main parts, commands and queries. If needed to scale this up, we can split this microservice into two separate microservices. One microservice will handle commands, and another microservice will be handling queries only. In this slide, for example, I have split a single microservice into two separate microservices. On the left side, I have products microservice that is responsible for handling commands, and on the right side, I have products microservice that is responsible for handling query side. Each of these microservices can be deployed independently of each other, and if needed, we can start multiple instances of each of these microservices. The left side microservice that is responsible for handling commands, it can have a REST controller that will listen for HTTP requests like HTTP post, put, delete or patch, and it will have a command handler component that will process the received commands. The responsibility of this microservice will be to accept HTTP request, validate data, and update the application state. The database of this microservice can be optimized for write operations. When a client application needs to request some information from our products microservice, a request will be routed to the right side microservice that will accept HTTP GET request, will query the read database, and will return requested information. The database of this microservice can be optimized for read operations. And this makes our architecture even more flexible. If our microservice receives a lot of read operations, we can optimize its database for read operations. And if needed, we can start more instances of query microservice to service these many read HTTP requests. Now, one obvious question that comes to mind is, how does information from the write database on the left side gets into the read database, which is on the right side? And the answer is with the help of messaging. The command handling component on the left side microservice will process the command, will persist information into the write database, and then it will publish an event message that will be stored in a special message queue that is outside of this microservice and that is global to all microservices. For example, this event message can be product updated event, and it will contain information about the updated state of our product. All interested microservices in the product updated event can consume this event and will process it. For example, the right side microservice will have an event handling component that will consume product updated event and will update the read database to make sure that the information it has is consistent with the information that is in the write database. And because the communication between these microservices is done via a messaging queue, we achieve location transparency. The two microservices are completely unaware of each other's location. A microservice that publishes an event message is not aware of how many microservices will consume this event message or where this microservice is allocated. And this is called location transparency. Later in this video course, we will add another microservice to the flow, and all microservices will be completely unaware of each other's location. There is no tight coupling between them, and they can be deployed and scaled independently. As we continue to the following video lessons, I want you to remember the difference between three different types of messages that are being used in CQRS design pattern. The first type of messages is command. Commands are used to express an intent to change the application state. An example of command message will be create message command or update message command or delete message command. Because a command is an intent to make a change, it's usually named in the imperative tense. For example, create product command or update product command or delete product command. And as you continue with this video course, you will learn how to create and how to use command messages. But for now, just try to notice the difference between the command and the other type of messages. For example, the second type of message that we have already learned in the previous slide is a query. And queries are used to express a desire for information. When creating queries, we will usually name them with a find or with a get prefix. For example, find product query or get user query. And another message type is an event. Event represents a notification that something has happened. For example, when a new product was created, our application will publish a product created event. Or when product details were updated, our application will publish an event with a name product updated event. You will see how to create and use each of these type of messages in the following video lessons. And CQRS design pattern is often used with another design pattern that is called event sourcing. And in this video course, we will use CQRS together with event sourcing. So let's learn what is event sourcing next.